And our next speaker is Mr. Philippe Schulzinger, Asia Regional Director, Business Line Transportation, Egis Rail, Thailand. He will be talking about LRT, Tramway system and operation. Please welcome Mr. Philippe.
Good afternoon, everyone. So today, on behalf of Egis, I would like to say first that I'm very honored to be present and have the opportunity to make this presentation about Tramway that I believe is one of the future key components of secondary city like Chiang Mai, Phuket, or Khon Kaen, and that I would like again share our knowledge and experience from Europe. Before, maybe just for people who don't know necessarily Egis, so some key figures about the group. So Egis is a French consulting company. In 2022, we did a turnover of about 1.5 billion euro. So the particularity of Egis is that we have two main activities. 80% roughly is about engineering, consulting and design, and 20% is about operating infrastructure assets. So you can see, for example, we are currently in a concessionaire for 20 road companies, expressways. We are also operating and maintaining 20 airports, and also 21 urban parking contracts in Europe. So Egis Group is about 18,000 engineers and people, staff, 75% consulting design and 25% for O&M. We are obviously a French company, but with majority of our activity being done outside of France, so we are very international. And you can see in terms of a breakdown of activities, so 20% is related to rail, so this is our major part for transport. Then roads. Also, we have a business line related to building, urban planning, and architecture, which represent about 25% of the activity, and 20% other related, like for water, ports, maritime works. In terms of Egis global offer, so we can service our customers and work with partners for the full, I would say, life cycle of any project related to transport infrastructure, urban, also development, and energy and industry. So from feasibility studies toward the full implementation of a project. And as I said earlier, also in terms of operation and maintenance, we provide also services. In terms of our local footprint in Asia Pacific, so we are present in Asia since 1955. And today, in fact, we are about 2,000 employees in the region. What is very important for us in relation to Thailand, Thailand is our transportation regional hub. We are present here for more than 30 years in Thailand. We have about 120 people, staff, working mainly in rail and civil infrastructure works. We have also a team developing MEP and also urban architecture activities. What is important to know, it's for Thailand, again, we are a regional hub, but also for the rail activities and the civil. We have, since last year, been more world, I would say, support for Egis Group. So today we are supporting regions like Middle East, Europe, and also Latin America from Bangkok. Roughly, we have 80% of the staff in Thailand are from Thailand, and the 20% are remaining are from different nationality, bringing different experience. So in terms of LRT system, I wanted to maybe share about, okay, what is LRT, what are the different advantages, in terms of system, how do we break down also the different components, and also share also some experience about operation and maintenance. So first, objective of an RRTC system. I'm sure many of you know these pictures about the representation and the comparison between cars and without cars and a tram for transporting, for example, 200 people. So 200 people, if you see the picture on the left, is about 177 cars average, and it's represent quite a major traffic. Obviously, on a light rail train, you can see on the right, if you put this same amount of people, in terms of footprint and I would say transport capacity, it's making a big difference. So the objective of the LRT system, obviously, is to reduce the number of cars in the city. So meaning reducing the pollution, reducing the impact on the noise, and of course the time for people to commute from point A to another point B. So it will also improve, I would say, the quality of living in the urban environment in terms of accessibility for people moving, and in terms of social and economic, obviously. Transport quality, and it will be improved in terms of reliability, speed, comfort, and capacity. Also, what is important, it's in terms of the city image. It will improve, obviously, the image and the iconic, I would say, image of any city developing a light rail versus having only car in the area. One thing also from a light rail perspective, it offers PPP opportunity in terms of how for delivering this kind of project. In terms of characteristics for segregated systems, so obviously you can see on the two pictures, with the segregated system we can increase speed for the transport. It will give also priorities in terms of traffic, so it will be more reliable in terms of timetable for the tram. In terms of capacity, also will improve the headways, and also we can provide a longer vehicle on a segregated corridor. Again, in terms of attractivity, it's more accessible, silent, and it's part of a network in terms of connectivity. Also, what is interesting to acknowledge in terms of energy efficiency, to compare tram with bus, diesel bus, and also electrical bus. So some study for comparable, I would say, capacity in terms of passenger transportation show that energy in terms of tram is still more efficient per passenger versus, of course, diesel bus. You can see the graph in the middle in terms of energy consumed for acceleration energy or cruise energy, and also for electrical bus. So this can be explained mainly due to the coefficient of resistance comparison between a steel wheel on steel rail with a tram and rubber tire on roads. So in terms of energy, again, that's the point that I think we need to bear in mind when we look at mobility and transport planning for Thailand, also with a target of decarbonation and energy efficiency. In terms of European tram benchmark, so you can see here on the slide the different characteristics in terms of the rolling stock, non-polluting, comfortable. It's quite large usually. We have also fast and frequent and reliable because we use mainly a dedicated corridor in the different cities. We have, so it's quite accessible in terms of a platform for passenger of any with any disability because we use low floor vehicle. Also, it will minimize the civil infrastructure for stops. It's quite also integrated typically in a urban landscape in terms of the street arrangements and also the overhead catenary when we use overhead catenary for the tram. We have public address system, obviously, in different tram stops. And typically in Europe also is quite connected with other transport modes. In terms of ticketing, we have cities using the same fare collection system from a tram to a metro to a bus. In terms of typical components, so we can break it down into three components. The first one is infrastructure, which can be fully or partly segregated, and we can have any type of, I would say, infrastructure in relation to the tram. Can be at grade, can be underground tunnel, can be elevated. Second component is a rolling stock, which will determine the capacity, the performance, the comfort, also the way we'll have the image of the city reflected through the design of the tram. And then we have the rail systems, which will provide the information, the telecommunication system, mainly traction power system, and the track and signaling. In terms of rolling stock, so typically the rolling stock manufacturers, they can propose many type of design. You can see a different image here, which show a completely different design, obviously. The particularity of a rolling stock I will show here, it's typically for LRT, consists of modular sections. So it's quite easy to, I would say, extend the capacity of a fleet by adding several modules when the operator or the concessionaire of a line decide to increase because there is increased demand. So it's a modular composition. As I said earlier, it's a low floor, so you can see on the picture in terms of access for the people, it's quite straightforward. There is no risk of gaps. It's a guided system with a track, and it can be, again, in terms of design, and you can see the different icons in terms of the cabin, of the cabs. It can be tailor-made for the need and the test and what the client wants. In terms of modularity, yeah, as I said, so can go from short tram to longer tram. So typically, 20 meters is roughly the length of a basic tram. And by adding different modules, you can see we can pass from 20 to 30 or even 40 meters. Of course, increasing accordingly the capacity of passengers. So we can go from 140 passengers per tram to up to 300 passengers, for example. In terms of infrastructure, so the station can be decided in terms of integration in the cityscape, depending again on the city, I would say, environment and the will of the people living there, the politics. In terms of, we want the station to be very visible, so you have the choice. For example, here you can see on the first picture, everyone can see the station from far, or it can be very discreet, just a flat platform with not even one canopy here in this example you can see on the right side. In terms of accessibility, so there is several, I would say, options that can be, again, we can play around, again, depending on the physical constraints and the city itself. So you see, for example, on the right, the different cities of Birmingham, Lyon, and Nice, with the different type of arrangement, or is it integrated? As I said, again, the access between the platform and the tram, because it's a low floor, is quite straightforward. We have some typical, I would say, constraints in terms of gradient, but it's quite, I would say, flexible in terms of gradient in stations. And for access ramp also, we can put access ramp on the side. You can see on the graph at the bottom to have people with, for example, disability who can access the platform easily. Again, station accessibility, some example. We can have a ramp also coming out from the tram. So in terms of operation, what is often the challenge, I would say, it's interaction between the tram and pedestrians, because the track is embedded and the system is embedded into the urban environment, and people can cross the track if it is integrated with the roads, like we can see here. So this is important to acknowledge. In terms of system, we have different also approach that we can implement. There is, for efficiency of operation, obviously the traffic priority is the best approach for tram system, meaning that when there is a road crossing with the tram, then there is a system of signaling with mass detection, typically, that will trigger the road traffic to stop the car traffic, and then having the tram arriving prioritized. Then that will help for the mass transportation. Typically, we have one OCC taking care of the full network of the full line. For security, we have like a metro lines CCTV system. We have also we have a PA display, etc. And for passengers, so access control, ticketing. So it can be made on any type of control. Can be at the tram stop, can be on board of the tram. In terms of environment, so it's quite friendly, zero emission. It got a limited noise and vibration impact on the environment. And typically also we have technology or techniques to have, also if we use overhead catenary, to have a specific design to integrate the overhead catenary into the environment. Or even now we have also solutions with no overhead catenary on batteries or with a charging point, or having feeding electrical system through the ground, like in Bordeaux in France. So here you have different, I will say again, configuration and cities mainly in Europe. And you can see the one on the right, bottom right, from Bordeaux, which is from Alstom, where there is no overhead catenary and the electricity is fed from the ground. So in terms of typical urban integration for the track itself, track corridor, so we have I will say in a summary, five typical options that will show some example. And again, here you see the different, just for information, so the one in Saragosse, it's on battery with a charging station at the tram stop, so no catenary. And again, the one underneath is from Bordeaux with no catenary and power through the ground. So axial track, I would say it's maybe the preferred one, depending again on what can be done physically in the city. It provides a good commercial speed because it's like a segregated and corridor for the tram. It's the pedestrians are using, I would say, the side walkway on the other side of the road, so there is less risk of pedestrian crossing, etc., and walking on the track. It's easier also for the organization of the maintenance and the operation of the system, again because of the segregation. And it's an easy flow of the different road users. because for crossing, it's more straightforward with a crossroad. When you have lateral tracks, so it's both tracks on one side of the road. So this can be okay, I would say, if you have, for the car traffic, one way, it will be better. It's also feasible and easier if you don't have too many private access on the site. And one of the inconvenients, you will have to be low speed because, again, you will have pedestrians walking next to the track. Then you have bilateral track options, which is not very ideal for operation because you have to operate and access for the maintenance to separate tracks. It's possible where you don't have, again, too many private access on both sides of the road. And again, same than before, you will have a lower speed than segregated corridor because of pedestrian interaction. Then you have the on-street track that sometimes we cannot avoid. It's where you have the mix used between the car and the tram using the same corridor. So on this configuration, you are, I would say, like a bus. You are dependent on the road traffic. So you will have, it's good when you have a low car traffic, otherwise you don't have the advantage of the tram anymore. And again, the speed will be very lower because of this interaction with the cars. And you have also the pedestrian on the side. And finally, split tracks. So it's very rare, but it can happen. It's where you have physical constraints in terms of, again, space for the corridor, and it's not possible to have the two tracks running in the same street. So it can happen. It's not ideal, obviously. It might be a solution when you have very narrow streets. It's more expensive because you will have to build the system on two different streets. So you cannot, I would say, optimize the works. It's like two sites, and not ideal for operation again. Also, I wanted to share with you some figures and some also experience on CapEx and OpEx for tram. So here you can see, based again on French cities, okay, for trams, a typical cost breakdown between the different activities. So what can be noted, first thing which comes to the eye is 1/4 of the cost for the CapEx is related to the rolling stock. Of course, you have also the one important cost center, I would say, which is the civil works, including the track beds and the utility relocations. In Europe, so where we have I would say all cities with a lot of utilities in the ground. When you build a tram, you have to relocate the utilities. And depending on how these utilities have been built in the past and recorded on drawings, it can be very challenging in terms of the construction. And I know also, for instance, that in Australia, for like cities like in Sydney, for the Sydney lateral, for example, there were a major challenge related to utility relocation in the city, especially in George Street in Sydney, because of a lack of accurate information. So I would say for city in Thailand, when it's all cities, it will be a challenge because in terms of records, I'm not pretty sure about how it has been recorded in the past. But for new cities, greenfields, that this aspect will not exist, so that will be also an optimization. So I know, for instance, for EEC, the Eastern Economic Corridor, where you have there is plan to build some smart cities and with mobility solution for people. That might be also a good solution to look at Tramway. Then in terms of tram type, we can summarize in four types: conventional, short, economical, express. And you can see on this table, I won't go through it in detail, but it's like a shopping list. Again, depending on what is the main criteria for the customer in terms of urban integration or building or interstation distance, vehicle capacity, headway, or cost per kilometer. Then depending on, again, the priority of this type of criteria, the client can look and I would say, again, like a shopping list, say, okay, I want my cost to be the minimum, then I will look first at maybe an express mode or type. Or if I want a full urban integration, so maybe we'll look at the conventional or short. And after he will, that's the idea really of this table, is to see what criteria will imply what type of system and what will be typically the impact. In terms of operation and maintenance, typical organization, so typically it's 3 pillars, one related to management, shared function or transverse function, like human resource, health and safety, environment, financing, legal, etc. One pillar related to operation, so with the control center, management, the ticketing, and all the security. And one related to the maintenance, with different teams for the different type of system for the maintenance of the system. And here I wanted to show you an example, which is for Parramatta Light Rail in Sydney, which consists of 12 kilometers of dual tracks, 16 stops. They have overhead line equipment with some free zone of catenary free zones. It's a 44-meter long vehicle. There is one depot, one OCC. There is a backup. And you see the organization chart of the operation and maintenance concessionaire. So you find again on the right the operation management, the pillar operation management. There is after right from left, so the maintenance pillar that here is called head of asset management with a team for the different maintenance of the system and infra. And then I would say the other, soft skill or soft organization related to the HR, safety, the customer relation, and the commercial, including the finance, etc. In terms of operating costs, so we can, let's say, break down into 4 main aspects. The first one is related to the personal cost. The second one for the spare parts, the supply, and the insurance. And third one, energy. And the fourth, structure costs. To be noted that in France, the average operating cost for a tram is around 7-8 euro per vehicle kilometers. Now, in conclusion, I wanted to emphasize on 5 pillars or the 5 key success for implementing a tramway in Thailand. So the first one is in relation to government support and policy alignment. And it's where I think it's important to have an organization like RRTC today that is there also to harmonize and coordinate between authorities and private sectors to have this type of alignment. So this shall ensure in terms of proper process, proper standard, robust standard for tramway, proper process for the procurement, also in terms of land acquisition, land use. So all this type of, I would say, policies that needs to be defined in advance. Second one is related to have an early engagement with local stakeholders. So mainly to have the support of the politics, and also that the public, the people living in the city are also willing and buying the tramway system. Third one is to have a comprehensive integrated planning. And of course, we have feasibility study, a process, etc. But really looking at a city is to look at the different poles of attraction. It can be a specific business center, commercial center, can be an hospital, can be universities, and see how to connect all these different points and make the system attractive for the population to make their life, I would say, better in terms of commuting, and then having the revenue also for the system. Fourth one, is to have an effective project management in terms of designing and building such projects. And the final one is also to develop local competency, typically, again, with a manufacturer from international background, engineering company, to have a connection with local university, local I would say schools, to ensure that we develop the local competencies. Then we have, I would say, the local people who can also operate and maintain the tramway in an effective manner for the future. That's it for me, and I would like to thank you again for your attention. Thank you.
Thank you very much, Mr. Philippe, for your valuable presentation on tramway system and operation.